Hello, good morning, everybody, and welcome to this new edition of our webinar series Starburst in Action. Today, we have the honor to have Kleber Barbado and Kevin Fischer from our Starburst customer Thinksurance with us. They will tell us and explain to us how they could ensure real-time data quality and data democratization within Thinksurance. The webinar is supposed to take about 30 minutes. If you have any questions, please feel free to put them into the chat window to your right. We'll make an effort to answer those as soon as possible. With that, I want to hand it over to Kleber and Kevin. Thank you very much.
Thank you, Corby. So we are here to discuss about this way that we made this transition from the Hadoop Hive cluster that we had a lot of things done into the Starburst engine with real-time quality and the possibility to democratize the data to all the departments of the company. So first, we are going to make an introduction about the Thinksurance. We are going to talk after about the migration itself. And finally, we are going to tell about what we have learned about this process. Thinksurance is a company that is founded in 2015. And today we are the leading position in commercial and industrial insurance for the intermediate with the biggest insurers over the Germany, and also most of the brokers, the biggest brokers either. We made this process with a lot of efficiency, data-driven decisions making, empowering on your users, and making a really easy way to them to manage this insurance process that is really, really complex. When we are talking about insurance, it's a really complex process because it involves a lot of questions, risks, changes over the path that can affect the contracts and can affect everything around it. What makes our product a little bit complex in the logic and in how to manage the things. And this is reflected on the data. Before that, let's talk about what's the size of this migration.
So I want quickly to give you like an overview over the setup in our old Thinksurance data warehouse. So we had a warehouse with over 200 schemas, 2,500 tables, roughly over 2,000 processes, almost 100,000 lines of SQL code, and almost 400 dashboards. And as you can suppose from the sheer amount of dashboards, for us, it's really important that we have data quality in place in order to make sure that we are delivering correct data to our customers. From the volume, we are talking about 6 terabytes of data. We had 5 S3 buckets, 4 AWS accounts, over 20 repositories, and we have streaming and batch processes. When it comes to costs, of course, we have to divide the costs into multiple segments. First, of course, is the execution costs. So our cluster for the ETL process run over 8 hours because we always process almost everything from this 6 terabytes in each evening run, which is for us really important because we have also updates, and these updates can go far back in the past. So we have to make sure that these updates also get considered. From the costs, we almost spent 6K per month for our warehouse. And in the old Hadoop environment, error recovery was also quite difficult. So when we had, for instance, some issues, it took us a little bit of time to recover from that. As you can also imagine, when we're talking about an Hadoop environment, we're talking about an entire ecosystem, which can basically be seen as a IaaS solution. So we also had to maintain our clusters. We had to make the patches. We had to update our versions, which of course is also some side task, which is not directly related to the focus business of Thinksurance. And because of this long execution time, we also had longer developmental cycles, which for us was sometimes a little bit complicated. Especially, but I want to especially stress the fact of these 8 hours execution, because for us, in order to get a good data quality, it is really important that we are able to run our processes multiple times a day and not only like in a single night execution.
Okay, talking about this process, we have some challenges and solutions.
So from the challenges and solution, you also have to know we were basically a team of 3 engineers, where I would say like 2 engineers were dedicated for this project. So what we needed, of course, is we had like over 2,000 tables to migrate. We need some help for the migration, and there we could found in Starburst Galaxy the schema discovery tool, which basically allows us to just put data into an object storage, and with schema discovery, where we then be able actually to get the correct schema, which was a huge time saver also when we compared it to other techniques. Also, as I mentioned, we had also different databases. So we have like a MySQL database, we have Mongo databases, we have some data on some S3 buckets. And with Starburst Galaxy also, right, we have the possibility to run federated query, which means basically we can access all these data independent where they are located and run them in the same query, which is also very helpful, especially when you have like a lot of ad hoc requests. You do not want always to bring the data really to the source. So you just want to query from the source and not just bring it always to your data warehouse. When it comes to the execution time, as I mentioned before, we wanted really to reduce our execution time. And then, of course, with the Trino engine, this is like a lot faster than when we are using, for instance, Hive. This is mainly related to the fact that Trino does a lot of in-memory computation when possible. So we have a reduced disk I/O, which also like reduces the bottleneck for that. As well, Trino has the pipeline execution, which means when a worker is finished with some parts of its workload, it can propagate the outcome of that task to the next step in the pipeline, which also leads to a lot faster execution. And also really helpful is that Trino also does the predicate pushdown, right? So sometimes it allows you to already put the where clauses on the source itself, which also reduces the amount of data which have to go over the network. Of course, we also spend 6K per month for our data warehouse, and for our company, that's some amount of money. So we also, of course, wanted to reduce the costs. And this is possible because in Starburst Galaxy, we can create different clusters, basically tailor-suited for your workload. And you also have the possibility to outscale them. In our old setup, we also had the issue that we had like a lot of complexity in our transformations, and in Hive we had to create our own little Java's jobs for the UDFs. And this was also like drastically decreased by using the Trino functionalities, especially with the functions, and the functions also support method overload and are really extendable. So this made it a lot easier for us to perform all the transformations needed to create valuable business assets. And last but not least, we also have the upcoming challenge that we have more and more unstructured data. Let's say we have, for instance, some images, and we want also to extract information from these images. We can now put everything to an S3 object storage, and then running the computational engine provided by Trino with the combination of the Iceberg file format basically allows us to have our own Starburst Galaxy Icehouse.
Okay, talking a little bit about the old architecture that Kevin mentioned, we used the Hadoop, and I lived with many data lakes over my career, and now every data lake has a special feature. In this case of our company, our data lake is not so big because we are talking only about 8 terabytes, but it processes most of these 8 terabytes every single evening, what makes the processing load very big. especially because we are talking about situation that the past interferes on the current situation. So we need to look at the entire past to take decisions for today, every time. And Hadoop is a great functionality for customizations of the processes, what makes it a good provider for that. But you need to manage and you need to contain every single box of this, what makes it very expensive in a maintenance mode. Okay. Then this is the moment that we can discuss about the new environment that we created. As you can see here, we could spin off the process. You can see that the lines are more fluid, and the process itself, it's been divided between IaaS, that's what we have in the light orange, and what we have in the SaaS on the Starburst delegation process, that's on the purple. This is really nice for this momentum, because then we can, if you take a look here, we was able to unify what we have in a batch process that is coming from this MySQL into the direct connector that we have from Trino. We are talking about the upper part of the draw. And with this batch process is the data that's not so used to be changed, it's more statical format, together with what we have in the microservices. And everyone that worked with microservices understands that when we are talking about a data lake that integrates with microservices, it's always a little bit complex to retrieve the data. And also, especially if we need to make this process to check every single change that was done, because for us, all the changes, all the actions done over the product can interfere on the decisions that we are making to help the client to make the best contracts for over the market. In order to do that, this draw was made by the contribution of a lot of expertise, a lot of people that was very smart and domain their areas. And this was the best way to get into this good architecture that we are presenting to you. In order to transform what we have into a streaming pipeline, into a series of sequential process that can be presented and analyzed together with the batch and creating a context of actions, we use the Debezium. So with the Debezium, we are able to get from multiple sources of the microservices the exact sequence. What we agglutinate into groups of execution rows in sequence using the Kafka to provide us on a staging S3. And here is when the Starburst solution provided us all these possibilities because of flexibility of Trino. This flexibility of Trino that allows us to connect to different sources with different types, with different organizations that made this possible. Even creating external access that we need to access systems with APIs and get the things very granular level that we use NiFi for that. Also was possible to integrate everything in one single standard entrance for the streaming. That's what we have in this middle S3, that's the staging S3. On this momentum, we decided when we just entering on this purple part of the process that I'm going to show now in more details, that we just entered on this part that we are in Starburst. We used all the functionalities that Starburst provided us in order to get the real-time quality. So the first part, we follow the layers that Starburst suggests about the landing structure and consumption, but we divided it into micro stages over these layers. The first micro stage that we did is the landing schema, where we just used the Hive engine, because Hive engine has the possibility that you can just fill the files on the storage and it identifies the data automatically. what does not causes any trouble to identify all the data that is coming from NiFi, coming from the Debezium, behind the knowledge of the Starburst environment. And for every time that you are going over this draw, you're going to see 4 layers of this pencil, one with gray, one with red, one with orange, one with green. These pencils is the layers of tests. We discovered by our experience in all over this evolution of the data lakes that we have faced, that as early as you identify the error, easier it will be to fix, and as fast you can error out, better it will be. So if you look on this structure layer, that's the gray one, is when we test about the broken structures, very gross, like just like we cannot even think about starting because the things came completely broken. From that moment, we had an iceberg engine table, that's the staging, because icebergs allows us to change the data very easily, especially because once we have this staging, landing to staging, we create a tracking ID, a unique identifier for that streaming row that came to us. So it's easy for us to identify what we need to do if we find a broken row. This one comes to a test layer that we check what we are going for the minimum structure data, because we received it completely unstructured and we need to make a structure in order to process it in a minimal way. And then came a great idea from our engineers to create this quarantine zone, because every time you're going to normalize, to break the things in multiple tables, to spread the data, if you find an error on a column, it's a nightmare to identify every single row on multiple tables that is affected by that error. So what we made, if we have this testing layer in the quarantine and it fails, we go back to staging, take actions on the row that generated that error by the track ID, and then we restart the entire quarantine schema by the scratch. What makes it so fast and so simple to treat the errors that creates us these real-time actions. Once we have this passing the quarantine, the tests themselves, we can trust that the data by itself, the structure of the data, not looking on the context, not looking over other microservice domains, but by itself trustable. Then we can place it on raw. That's when we start the structure layer. Raw for us will be a historical depot of the data. So we have all the micro actions done. This is very important for us for the artificial intelligence, for the data science layers. But for the analytics, it's not so useful. That's why we place it on another iceberg that's on the cleaned, because on the iceberg, we can make the merge and just change the data that's really different. And then using the functionalities of the iceberg of the historical schemas, validations and changes, we can see what is changing over the time, what's really useful. Finally, the last quality layer that we make, this is more sparse. This is not this does not happen every time, but because this is going to check across entire microservices domains validation. For instance, we can have a data that is really good, for instance, the client name, but this client name does not match with the client name that we have in another microservice. So this is more like integration tests. This, from our perspective, we are making also even backups. That's also something that Trino's, the Starburst process, helped us with the flexibility of Trino to make backups of these, snapshots of this, so we can look over the time and see how the row was. If someone corrupted something, we have a disaster recovery very easy either. Based on what the errors that we find, we always learned also that is really important and crucial if you want to have a consistent process, to have a traceability over the entire process, and also an auditory about what happened and which action was done in order to change and fix the environment. And because of that, we created two structures. Sorry. First, we created a table called the recycle bin. A little bit of humor, but that's the name of the table. Because every time that something breaks on the quarantine, we documented everything that was done to fix this record, if we excluded it, if we discarded it, or if we fixed it manually, or if we requested a new version of it. This is marked on this recycle bin like an incident tracking. Finally, we have, every time the things get out of the quarantine, we place it in an auditory table injection. So we have all the history, row by element by element of the that was injected on our data lake, when it arrived, how it arrived, and for each process it went, for each tables it went. What gives us a very granular and statistical process about even calculating the peak hours that we have the usage of rows, when it's used, and which functionalities are more used and which are less used. Because since we are talking about microservices, and we, by the BISIM, we have this real-time integration, we can analyze the usage and the data flow over the entire platform in a very granular level. And this was possible either because this speed that Trino provides us using these iceberg delta checks, that we were able to have this tracking so in real time and in so granular level. Just talking about the interference, we already, after we have migrated this, we already have had two versions of something that was changing on the product and affected our data. So we have two major broken executions of the quarantine, and we were able to solve this and get the production completely running back in 5 minutes with only one person acting on it. Now, talking a little bit about the benefits and the cost that we really impacted us.
Yeah, so as Kleber already showed, right, the design of our new data lake or new ice house, we are now finished the first phase of our migration, and we can already have some resumes about the impact. So we divided that into the benefits and the costs. One thing is we were able to reduce the execution time by roughly 60% currently, and we are still on phase one. We expect that we can go down to 80%. And this will be, for us as a company, a great enabler, because that allows us to run the entire process multiple times a day. And we can make basically sure that always on the next day our data are served to the customer. Yeah, this is a huge changer for us, because before that one, we had to wait 8 hours, and then in the next morning it could break because of some tests failing, and then we do not have refreshed data. And this is completely changed in this new infrastructure. Second, we also talked about that we want to accomplish democratization within our company. And we can also here draw the first resume. This is quite possible now, because in Starburst Galaxy we also have very sophisticated data governance tools. So we were able to create good descriptions of our tables. We could create the entire lineage, making data products. So really helping people to understand what our data assets are, how to combine them. And this is very important. But what was also for us a real game changer is that in Galaxy we can also have role-based access management. So we took a great effort within our company to map all the different roles we have, beginning from CEO, CTO to data analysts, engineers, and created then the permissions on the ice house accordingly. So everyone has just the permissions he needs to be able to do his job. And also then we are compiling to the GDPR requirements. And this is quite important and was not possible in the old infrastructure we had so far. So we can now open basically this entire icehouse to our company with having all the security measurements in place. Then next thing is we were also able then basically now to first run our first unstructured data. We could store them, extracting the value assets from them, because the important thing for us, at least from the icehouse, is that we are going more now to a schema on read and less a schema on write. So we can first place all the necessary information, managing them quite well with the catalogs, and then always extracting insights from these unstructured data if needed. From the cost base, the bill of our cluster reduced by around 30%. This was able to the customized clusters that we have, like larger clusters for higher transformations, higher data load, and small clusters when we have even just very little data to transform. We also have, again, an optimized infrastructure, as you could also see from slides before. Before that, we were in this Hadoop ecosystem, but now we are entirely on a SaaS solution, so we do not have to maintain, we do not have to update our Trino versions, and we can really focus on what drives our business forwards. And last but not least, but at least we experienced that as a very nice thing, that we are completely SQL driven. Since Trino is basically running over the SQL flavor, we were able that also analysts, engineers, different departments can start with creating their own queries and drawing insights from the data. So everything is in the same language with a very sophisticated set on functionalities, and we are currently expecting that this is reducing our developmental costs by around 25%. So when it comes to lesson learned, I want to give you also some key takeaways, what at least we experienced in this migration project. First of all, for all, pool resources and knowledge across departments, which means to migrate an entire data architecture to a new solution takes more than just a data team. So we closely collaborated with DevOps in order to implement this CDC pipeline, which Kleber was showing. We defined with different stakeholders of the company all the access pattern in order to compile to our GDPR regulations. And also we talked to platform teams to see how we can having recovery scenarios in case something goes wrong. As Kleber already mentioned, we already had 2 issues and we were able to resolve them quite quickly. Second, the engine is also important. Use all the different functionalities that Starburst provides. So we have a mix of Iceberg, we're using some Hive tables, we're using Org and Parquet, and really make it your tailor-suited solution. So for instance, when we are being on the staging layer, where we're saying, okay, we're just loading the data, checking for correctness, we are using mainly Org, because we're simply writing to these tables and we're not reading so much from it. So then, at least from our experience, Org is a little bit faster than Parquet. Parquet is better when we are going to the data lake itself, where everyone is querying over it. So we have like heavy read access on the data. That's actually better suited. Next point is establish traceability and auditory in the ELT process. So we really made a lot of effort in order that we are able to track down each record, that we can see from which file it was coming, what was the record on the platform side, in order to being able to really quickly trace back errors and having like a good auditory in place. Also quite important is use multiple test layers and think already about what would you do when a test fails? How can you recover from that error? Do you want to let the pipeline stop? Do you want to skip the test in some scenarios, or can you also adjust the data accordingly? This is also quite important from our perspective. So as we managed that one, we split that into 4 different categories, right? We had our structural tests, especially because of Mongo, where we checked if all the data types are fine. And then we checked for some invalid data. For instance, do we have some timestamps before 1970? Just like some really plausibility checks. And then we're looking also on the correctness of the data, like from a business perspective. Does these data really make sense? And also, do they integrate with other data coming from different services that we're not having some orphan IDs, for instance? Also quite important is adopt conventions and template workflows. So when you see that you can automate something and the workload of some tasks is quite similar, then trying to template them, especially when you're a small team, because otherwise it will be hard to accomplish that in time. And last and not least, in order to have a cost efficiency and performant icehouse, use different clusters. Think about the workload, think about really the hardware, the underlying hardware you really need to accomplish your data transformations, and yeah, trying there to also make a good suited solution. So overall, I can just say for us, the migration to Starburst was quite smoothly, and we see that as a really good partnership, and we could really profit from using all the functionalities which were provided within that technology. Okay, I hope we could provide you some valuable insights in our migration journey, and now we would love to hear your thoughts and questions. Thank you very much.
Kleber, Kevin, thank you so much for sharing those insights. I think those were really impactful. How you managed to drive this migration in such a small amount of time. Remind me, how long did it take you to get this from when you began to production?
So from the moment that we started the migration itself, we was designed to have only 2 persons on the project working, and the effort was 3 months. But since they are not fully dedicated, we took us 6 months to make the full migration of this entire line, even considering that we needed to also implement the tests to guarantee the quality.
Okay, cool. That is pretty impressive. Such a change from a legacy architecture to a more modern icehouse architecture with Starburst in just a few months of time. That's really great work. Fantastic presentation. Thank you so much. For everybody else in the audience, we'll continue this series. Of course, we'll have a webinar coming up with our customer Tatra Banka, a bank in Slovakia, where Patrick Plecho, who is enterprise architect, will share their story, how they got to modernize their existing Hadoop and Impala-based solution. So make sure to not miss that out. Use the QR code to register already now, or find it on our events page on starburst.io. With that, thank you very much for your attention. You got the contact details here. You'll get a link to the recording afterwards. And I wish you a very great and productive rest of the week and a good weekend. Thank you very much.
Thank you, guys, and feel free to contact us if you have any other questions.
Thank you very much.